Let's look at how we can construct our own truth tables. Let's make the truth table for it is not true that P or not Q. Okay, we're always going to follow the same process here. First, I look at what letters appear in my statement. Here I see a P and a Q. So I'm going to have P and Q as the input columns. I always alphabetize them, so I'll put the P first. Now, with 2 choices for P and 2 choices for Q, I have 2 times 2 or 4 rows that I need here. And I'll always fill in under my simple statements the same way, starting on the right, alternating true, false, and then stepping to the left and doubling up for true, true, false, false. If indeed I had a third value over here, I would double up again to 4 in a row. Now, the hardest part about making a truth table, I think once we've got it, is kind of figuring out what order the things should go in here. Really, that comes down to our order of operations. We're going to put each step that we would make, given values for P and Q, across the top here in order. So if I knew what P and Q were, the first thing I would do is definitely take the negation of Q. Right, inside the parentheses, negations before disjunction. So I'm going to make this column not Q. Once I knew what that was, I could take P and take the OR of it with Q. And then this is everything inside the parentheses, so the last step here is to take the negation. Okay, first step. I'm going to fill in the values here under not Q. I like filling in my values a column at a time. It makes the most sense to me, then I'm always looking at the right things. So if I look at this first row and just the first row, I see that Q is true. So in this row, the negation of Q should be false. So I'm going to put an F here. Okay, and that's all I've done. In this first row, Q is true, the negation of Q should be false. In the second row, Q is false, so its negation should be true. In the third row, Q is true, so its negation should be false. And in the fourth row, Q is false, so its negation should be true. Okay, all I did to find those 4 values were take the values for Q in that row and flip them using the negation idea or table. Now next, and this is tricky, I have the values for P. I already know what those are. I have the values for not Q. We just calculated what those were. So what we're missing here is this disjunction symbol. That's how I pick what table I'm going to look at. Okay, we know what P is, we know what not Q is. What we're missing is this V shape, which is disjunction. Now, the more truth tables we do, the easier it will be to do this, but I'm going to cover up this column for Q because I don't care what Q was. All I care about is the value of not Q and the value of P. So, to find this, what I'm thinking, and normally I won't write this down because it just really clutters up the table, is my first input here, P is true. My second input, not Q here, is false. So looking at the disjunction table for true first and false second, I see that this should give me a value of T. Okay, I'm going to continue to write these in just because I want to make sure we know exactly where they're coming from. In this second row, P is true. Disjunction is what we're doing. The negation of Q is true. So in this row, I have true or true. That's going to give me a true from the top row of my disjunction table here. In the third row, I have that P is false. I have that Q is false, or sorry, the negation of Q is false. So first input false, second input false, gives me an output of false. And finally, in this last row, I have that P is false, and I'm putting that together with a value for not Q, which is true. And false or true according to the disjunction table gives me a true. If you followed exactly where all 4 of those values came from, you basically know how to do any truth table. Okay, things to look out for, or things to make sure you're doing correctly. You need to be looking at the correct columns, which is why I covered up Q here, because I don't care about Q, I only care about P and not Q. You need to be looking at the right table, which is why I got out my disjunction table to sit it next to here. And then when you look at this and you see this is supposed to be a T, you need to write down a T and not accidentally write down an F. So those are your three things to watch for. You need to look at the right columns, you need to look at the right table, you need to put down a T when it says T and an F when it says F. Okay, finishing out this truth table is actually rather straightforward because notice I just did all this stuff and all I want to do now is the negation. So I'm going to take the values I had here and just negate them. So I don't actually need to look at anything that I did before this because all I'm doing is simply taking the values for P or not Q for each row and then flipping them using negation. So P or not Q in the first row was true, so its negation is false. P or not Q in the second row was true, so its negation is false. P or not Q was false in the third row, so its negation is true. And P or not Q was true in the fourth row, so its negation is false. Here's the full truth table for it is not true that P or not Q. Just like we did for our initial statements, we can make a claim about all of this. For example, it is not true that P or not Q is only true when it's only true in this row, so when P is false and let's see, Q is true, right? That defines this statement. It's the key to the statement. This statement, it is not true that P or not Q, it's only true when P is false and Q is true. We can also now use this like it's one of our normal truth tables. Let's find the truth value of it is not true that P or not Q when P is true and Q is false. Okay, I want the value of this statement when P is true and Q is false. Well, to find that, I just need to look where my first input is true and my second input is false, and then look across here, this thing is false in that row. Okay, so here is making a truth table, noting what a truth table tells us about a statement, and then using that truth table to look up values for it.